Good afternoon. Let's start today's our lecture. Today we will talk about information systems in medicine. Material we cover at this lecture is the health information technology, health information systems, types of health information system, and we will discuss some questions about telemedicine. Let's start with some definitions. Health information technology, abbreviated to HIT, is defined as information processing using both computers' hardware and software for the entry, storage, retrieval, sharing, and use of healthcare information. Two common components of health information technology are electronic medical records and computerized physician order entry. Before we start, we need to revise what does system mean. Some lectures ago, we had a lecture about general theory of the system. What is a system? A system is a set of objects or elements that interact to achieve a specific goal. System is a group of interrelated components working together toward a common goal by accepting inputs and producing outputs in an organized transformation process. At this picture, at this slide, you see an information system components. Information system is a set of people, procedures, software, hardware, and data. They all work together to provide information essential to running an organization. An information system that combines a computer-based patient record with other modules that support clinical workflow is called a hospital information system. Look at this picture. So components of information system are software, hardware, people, data or information, and procedure. Functions, we use it for input, output, control, and retrieve the data. Look at this slide. Database system environment is shown at this slide, which includes hardware, software. We have two types of software: operating system and database management system. And applications are people, procedures, and data. Components of a database system are shown at this slide. Database is a collection of related data, and data is a collection of facts and figures that can be processed to produce information. A database management system, or abbreviation DBMS, stores data in such a way that it becomes easier to retrieve, manipulate, and produce information. A typical database management system has users with different rights and permissions who use it for different purposes. Some of the users retrieve data and some back it up. We divide all the users into some groups: designers, administrators, and end users or customers. Designers are the group of people who actually work on the designing part of the database. They identify and design the whole set of entities, relations, constraints, and viewers. Administrators maintain the database management system and are responsible for administrating the database. They are responsible to look after its usage and by whom is should be used. They create access profiles for users and apply limitations to maintain isolation and for security. Administrators are also look after database management system resources like system license, required tools, and other software and hardware related maintenance. End users or customers are those who usually reap the benefits of having a database management system. End users can range from simple to sophisticated users. Let's look at some database terminology. First of all, if we are talking about database management system, we need to understand what is data. Data are basic facts or values. Every task a computer carries out works with data in some way. Without data, computers would be pretty useless. It is therefore important to understand the data are and how to represent and organize data. The term data is considered plural in the scientific community. A database, another term, is an organized collection of data. Instead of having all the data in a list with a random order, a database provides a structure to organize the data. One of the most common data structures is a database table. A database table consists of rows and columns. In database terminology, each row is called a record. A record is also called an object or an entity. In other words, a database table is a collection of records, and record is the all information about one object or one person. The records in a table are the objects you are interested in, such as the patients or the students. Each record consists of some specific parts, which is called a field. A field corresponds to a column in the table and represents a single value for each record. A field is also called an attribute. In other words, a record is a collection of related attributes that make up a single database entry. So at this picture, you can see the table from the database. Each table consists of records of rows, which is called record. A record is the full information about one object. Each record consists of different fields. Look, the first field is ID, next field is surname, then next field is age, then next is class, and last field is section. So each record consists of the same fields. Another name for table is the relation or entity. Tables are the fundamental components of any relational database. A table stores the data corresponding to a specific type of object. Another name of row in the table is record or tuple. And name of the column, another name for the column is the field or attribute. Model is a real-world entity having properties called attributes. Every attribute is defined by its set of values called domain. For example, in a school database, a student is considered as an entity. Student has various attributes like name, age, group, and so on. Entity relationship model. Entity relationship model is best used for conceptual design of a database. And entity relationship model is based on entities or tables and their attributes or fields. Among entities, there is different relationship. The most popular data model in database management system is the relational model. This model is based on the first-order predicate logic and defines a table as an n-ary relation. So between different tables, we have relationship, and each entity or each table hold different attributes. The logical association among entities is called relationship. Relationships are mapped with entities in various ways. Mapping cardinalities define the number of association between two entities. Now let's talk about different types of information systems. Health Information System, abbreviation is HRS, is a foundation for healthcare technologies in developing countries. There are an information management system that capture and display data related to the delivery of healthcare services. And health information system is not just a system of computers and software. It indicates clinical guidelines, medical terminology, dictionaries, and interfaces, the various diagnostic devices, and other clinical and business information databases such as laboratory, pharmacy, and diagnostic imaging. It is also used for public health and medical research purposes. The main function of health information system is to serve a variety of clinical and administrative functions. All health information system consists of the software itself and the hardware. Consumers can maintain a personal health network. Clinicians maintain an electronic health record which maintain information from multiple sources within the organization about the patient. Health information exchanges allow the transfer of information among various clinicians and patients. The exchange of information across clinicians within a region creates the Region Health Information Network. Several regional health information networks make up elements of the National Health Information Network. Many participants have high hopes for health information technology. Hospitals hope to reduce medical errors, such as ordering and administering the wrong dose of medications. Providers hope to access and share patient information more easily, thereby improving care. Governments and business hope to save money by improving efficiency. According to expert researchers, full implementation of health information technology systems could produce efficiency savings as great as 100 billions per year after 15-year adoption period. According to the government health information technology, medical professionals must pay close attention to confidential issues such as patient privacy and security safeguards to ensure unauthorized access cannot access the information. Health information systems abet communication between multiple doctors or hospitals. Patients' care is enhanced with the use of health information systems because electronic documents reduce the risk of medical errors caused by poor penmanship. Let's look at the benefits of using a database information system. Although some staff training or tutorials are required, these systems are user-friendly and staff can easily access what they need straight from their computers. People do not have to be technology experts to understand how to navigate health information systems. The next benefit of using a health information system is that files are easier to access. We have more controls if we use information technology system. It is easy to update information system and it maintain communication between multiple doctors or hospitals. Initially, health information systems were only used to simplify medical appointment scheduling, but eventually a patient's complete medical history was stored on them. Not only does this technology save paper, but it also allows instant provider orders, shared patient data, and comparison students that were previously impossible. All health information system consists of software itself and the hardware. Also, health information technology software is utilized on computers by receptionists and medical staff. The data is often stored and managed off-site by health information technology provider. Scanners and printers play a big role in electronic health records because of the amount of data that must be transformed into and from the digital format. Wireless routers are the next essential piece of full electronic health record system that allows doctors to work with laptops or tablets for ease of workflow. Health information systems are electronic software programs that solve a variety of clinical and administrative functions. Medical offices use health information systems for storing electronic patients' records, scheduling patient appointments, and setting up patients' accounts and payment plan options. Health information systems keep track of everything related to patients. This includes the patient's medical history, medication logs, contact information, appointment types, insurance information, and billing and payment accounts. Files are easier to access in health information system. Health information system have um, the way that doctors and healthcare professionals maintain patients' information. These systems are electronic, so the days of hard files and loose papers are over. Uh, More control. Staff must be authorized to access the health information systems. Doctors may have permission to update, change, and delete information from the electronic medical record. The receptionist, however, may only have the authority to update a patient's appointments. Easy to update if you use information system. Health information systems let doctors create electronic medical records for their patients. Patient information can be pulled up for retrieve at any time, and copies can be made for the patient upon request. Uh, costs cost information system is very expensive. If we're talking about small practice clinic, it is approximately $2,050 per month. And if we're talking about medium-sized clinic, it is approximately up to half of the $500 per month. But this depends on the demands of the clinical system it solves. If small practice is thinking about investing in basic practice management system for appointments, lab results, and referrals, then costs are only about $250 per month. If a medium-sized clinic with several doctors wants to integrate a full electronic health record system along with practice management software, they would be looking at 400 to 500 thousands per month, and an upfront cost of 10 millions for the first provider and 5 millions for each additional doctor. It doesn't include the cost of necessary computer equipment, data storage, scanners, printers, wireless routers, and individual laptops. So all health information systems are divided into some subgroups. Health information systems are information management systems that capture and display data related to the delivery of healthcare services. And health information system is not just a system of computers and software. It includes clinical guidelines, medical terminology, dictionaries and interfaces with various diagnostic services and other clinical and business information databases such as laboratory, pharmacy, and diagnostic imaging. It is also used for public health and medical research purposes. We will discuss some subgroups of health information system. All these types are divided into some categories: subject-based systems, task-based systems, decision support systems, expert systems, and artificial intelligence and administrative healthcare services. The most well-known type of health information system is the electronic medical record, or EMR, or electronic health record, EHR, which is the electronic equivalent for a patient's paper chart. The electronic health record is a subject-based system that captures and stores information based on a patient's name or medical uh, record number. It may also display information based on a physician's name. For example, a physician can view lists of her or his patients who are currently in the hospital. If we are talking about information system, we need to understand differences between traditional medical records and health record. It is systematic documentation of a patient's medical history and case. Traditionally, medical records have been written on paper and kept in folders. Nowadays, electronic health records are used. An electronic health records, or EHR, refers to an individual patient's medical record in digital format. An electronic medical record, abbreviation is EMR, refers to a patient's legal medical record stored in digital format. It serves as a repository for clinical data and may have additional capacities such as computerized physician order entry and clinical decision support. An electronic health record, EHR, is a subset of electronic medical record that is integrated into a larger information network and owned by the patient. In common usage, electronic health records and electronic medical records are used interchangeably to refer to a patient's medical record in digital format. At this slide, you see advantages, the comparison of using advantages of electronic health records over paper-based records. In the patient's care is enhanced with the use of health information systems because electronic documents reduce the risk of medical errors caused by poor penmanship. Also, health information system increase organization and eliminate the need for medical staff to file paperwork, which reduces their administrative burden. Complete patient data displayed in an integrated fashion that facilitates medical decision making. Access from any workstation in the hospital is possible. Ability to enter orders, notes, data at same workstation, so it is very convenient. No double entry of information. Next advantage is the immediately availability of results. Then simultaneous users can access some medical records, access from one site or remote locations, no loss of patient information. All these advantages we have if we use information system, if we use electronic health records system. Next type of information system is the task-based system. These systems are driven by the system, and they capture information and copy it to the electronic health report system. Task-based systems are those that capture and report information about specific healthcare related tasks such as laboratory, diagnostic imaging, and medication management or pharmacy systems. This is example of task-based system. Radiology information system. The radiology information system is a computerized system used by radiology departments to store, manipulate, and distribute patients' radiological data and imagery. A modern radiology information system is a prerequisite for the efficient management of a department of radiology. The system generally consists of patients tracking and scheduling, results reporting, and image tracking capabilities, used to support both administrative and clinical operations. Radiology information system components. Radiologic information system complements health information system and are critical to efficient workflow to radiology practices. Workflow is a term that can be used in any industry or in any organization. It simply means how a process is done step by step. In the radiology, we have always used the term workflow to describe how we complete an examination from order entry to transcript report. The workflow in each radiology department is different because there are many variabilities. At this slide, you see simple workflow within a radiology information system. Clinician orders a radiographic exam using the hospital information system. Within minutes, the order subsequently appears at the modality in list of patients requiring radiographs that date. The radiology technicians select the appropriate patients from the list and conduct the study. Once the images are generated, they are sent to a central local server, and the exam is automatically completed and charged in the health information system. By simply clicking the View Images button under the Images tab in the Health Information System, the images appear in an easy-to-use browser-based medical image viewer or on a digital imaging and communications in medicine workstation program on the local computer. In addition, the images and reports are accessible from anywhere inside the local area network and also potentially available outside the clinic network via the World Wide Web. Then at this slide you see a picture achieving and communication system. This system is a medical imaging technology which provides economical storage of and convenient access to images from multiple modalities, source machine types. A picture achieving and communication system, abbreviation is PACS. PACS refers to the host of technologies that contribute to the creation, distribution, and achieving of digital images. PACS has the ability to deliver timely and efficient access to images, interpretations, and related data. PACS breaks down the physical and time barriers associated with traditional film-based image retrieval, distributions, and display. The three steps of PACS are shown at this slide. The first component is the acquiring data from modalities, then storing data in a achiever, and then viewing it in a workstation. In a modern radiology department, most images are acquired in a digital format, meaning that the images are inherently digital and can be transferred via computer network. Ultrasound, computed tomography, magnetic resonance imaging, AMR, and nuclear medicine have been digital for many years and have been taking advantages of PACS far longer than general radiography has. A display workstation is any computer that a healthcare worker uses to view a digital image. It's the most interactive part of a PACS. Then these workstations are used inside and outside of radiology. The display station receives images from the archive or from the various radiology modalities and presents them for viewing. The display workstation has PACS application software and allows the users to perform minor image manipulation techniques to optimize the image being viewing. Some display stations have advanced software to perform more complex image manipulation techniques. At this slide, you see typical PEX components, which includes a digital imaging modality or device, network, and a chip device, diagnostic workstation, a chip and routing software, and some interplay with hospital or radiology information system. DICOM images. DICOM stands for Digital Imaging and Communications in Medicine. Electronic images and reports are transmitted digitally via PACS. This eliminates the need to manipulate file, retrieve, and transport film jackets. The universal format for PACS image storage and transfer is DICOM, Digital Imaging and Communications in Medicine. It's a standard protocol for the transferring, displaying, and storing of medical images data. Most modern imaging machines are capable of producing DICOM images. To manipulate with DICOM files, we need to use DICOM Viewer. It is specialized application software enables you to open, process, and interpret DICOM images. At this slide, you see examples of this DICOM software, MicroDICOM, Radiant, or another software applications. The basic requirements of a DICOM workstations are shown at this slide. The ability to query and send image files to multiple DICOM devices, including other workstations. Their capability to manipulate images, a health information system, radiology information system interface to link reports to the images, the ability to import, export other image types, such as JPEG, and convert them into DICOM, the functionality to allow dual monitor viewing, the ability to print DICOM images. The potential benefits of using PACS are shown at this slide. If we use PACS, it increased connectivity and integration between facilities and departments. Productivity improvements, less time spent looking for misplaced radiographs or ultrasound images, less time spent hanging removing films, less time distributing files. Simultaneous viewing of the same images in multiple locations, better image quality that analog film or thermal prints, provides an avenue for rapid consultation with specialists. Next type of information system is the next type of task information system is the laboratory information system. A laboratory information system, LIS, is a class of software that receives, produces, and stores information generated by medical laboratory processes. These systems often must interface with instrumentals and other information systems such as hospital information systems. Disciplines of laboratory science supported by LIS include hematology, chemistry, immunology, blood, um, blood bank, donor and transfusion management, surgical pathology, anatomical pathology, flow cytometry, and microbiology. Next subcategory of information system is the decision support system, DSS. Decision support system is an interactive computer system that can be used by managers without help from computer specialists. A decision support system has three fundamental components: database management system, model-based management system, and dialogue generation and management system. Decision support system extract data from various clinical and administrative systems and compile it in various ways to identify trends, analyze costs, or solve problem areas in operations. For example, an increase in the number of patients with a diagnosis of adult onset diabetes, type 2 diabetes, may indicate that a health care provider must expand its diabetes education services. A decision support system provides managers with the necessary information to make informed decisions. A decision support system has three fundamental components: database management system, which stores large amounts of data relevant to problem. The decision support system has been designed to tackle model-based management system, which transforms data from the database management system into information that is useful in decision making, and dialogue generation and management system, which provides a user-friendly interface between the system and the managers who do not have extensive computer training. Next type of information system is the expert systems and artificial intelligence. Mimicking human expertise and intelligence requires the computer to do the following: recognize, formulate, and solve the problem, explain solutions, and learn from experience. This system explains the logic of the advice to the user. Hence, in addition to solving problems, they also can serve as a teacher. They use flexible thinking process and can accommodate new knowledge. Administrative healthcare services extract information from clinical systems and use it to manage daily operations such as scheduling appointments and billing insurance carriers or patients for services rendered. A management information system is a computer-based system that provides the information necessary to manage an organization effectively. The management information system should be designed to enhance communication among employers, provide an objective system for uh, recording information, and support the organization's strategic goals and direction. Transaction processing systems. Transaction processing systems are designed to handle a large volume of routine recurring transactions. They were first introduced with the advent of mainframe computers. Transaction processing systems are used widely today. Banks use them to record deposits and payments into accounts. Supermarkets use them to record sales and track inventory. Managers often use this system to deal with such tasks and payroll, customer billing, and payments to suppliers. Operations information system were introduced after transaction processing system. An operation information system gathers comprehensive data, organizes it, and summarizes it in a form that is useful for managers. These types of systems access data from a transaction processing system and organize it into a usable form. Managers use operations information system to obtain sales, inventory, accounting, and other performance-related information. But there are three key pay points for healthcare service providers. First of all, it is high initial costs, the need for human resources to maintain and service systems in-house, then accessibility of data 24/7, a potential problem with relying on electronic communication and processing of information is the loss of the vital human element. Next type of information system is telemedicine. Telemedicine is the use of electronic information and communication technology to provide and support healthcare when distance separates participants. There are different types of telemedicine. Store and forward, remote monitoring, and interactive services. Let's look at each of these parts. Store and forward telemedicine involves acquiring medical data like medical images, biosignals, and then transmitting this data to a doctor or medical specialist at a convenient time for assessment offline. Then, next type of telemedicine is the remote monitoring, also known as self-monitoring, enables medical professionals to monitor a patient remotely using various technological devices. This method is primarily used for managing chronic diseases or specific conditions such as heart disease, diabetes mellitus, or asthma. At this slide, you see structure of the comprehensive disease management system. Um, at this slide, you see integrated telehealth platform supporting patients and healthcare professionals in the monitoring and treatment of diabetes. The MyGlucoHealth meter connects wirelessly to a mobile phone using Bluetooth technology to manage blood glucose testing information and communicate results to the My Glucose Health online portal. Interactive services, real-time interactions between patient and provider to include phone conversations, online communications, and home visits. The telemedicine system consists of customized medical software integrated with computer hardware along with medical diagnostic instruments connected to the commercially set, very small aperture terminal at each location. So telemedicine network configuration consists of patient and block, specialist doctor and block, and there is connection between these two parts. The patient and terminal has to prepare an electronic file of the patient's history and his radiological and pathological reports. The patient end must therefore have the facility to prepare these reports and convert this into an electronic record. The specialist and terminal has to receive the patient file and display the patient records satisfactorily on the monitor in order to enable the specialist doctor make a diagnosis. The specialist doctor should be able to write down this diagnosis and his recommendation for the line of treatment and send it back to the patient end. The link could be a simple telephone line, internet, or fiber optic or satellite line, depending upon requirements, availability, operational acceptability, and cost. The applications of telemedicine are shown in this slide. We use telemedicine as for remote consultations and clinical care monitoring. We use it in disease surveillance and program tracking, for continuing medical education and public awareness in the disaster management, in the disease management. We use telemedicine in home care and ambulatory monitoring. Mentored procedures and in surgery robotics, and we use telemedicine for second opinions in different questions and complex interpretations. So there are a lot of usage, a lot of applications of telemedicine. Let's look at the benefits if we use information technology in medical care. Health information technology enables more informed decision making and enhanced quality of care, saves lives through remote consultations, whether urgent or diagnostic, creates more efficient, convenient, and potentially more cost-effective delivery of care, facilitates earlier and more accurate diagnosis, provides greater and faster access to a patient's medical history, reducing the risk or negative drug interactions or poor response to a course of treatment, improves administrative efficiency and coordination, allows rural residents to receive expert diagnosis and treatment from distant medical centers, increases timeliness of treatment and decreases transfer rates while reducing medical costs through video technology, supports real-time treatment by first responders through the use of wireless devices, enhances senior wellness and preventive care through telemedicine and remote in-home monitoring. And let's summarize our lecture for today. So computers are an essential part of healthcare and also a necessity. All healthcare services have gained a greater ability to treat, diagnose, and care for patients through computerization. Every healthcare worker should have basic computer literacy. And bottom line, computers do enhance the quality of patient care. So I hope you will use computers in your future because it is a necessity. We finish with the lecture for today and only one lecture left. See you next time. Have a good day.